People do actually come to us now to develop pastes for them, to solve problems in manufacturing, to put in production lines for them if need be. And all that is done as contracted research. We also do a lot of government-funded projects. It's a very good way of becoming involved with other companies in not necessarily exactly the same business area, but who are there potentially to promote us and we can promote them. And a lot of the partnerships that we've had right from the early days we've actually maintained. And certainly with a lot of these companies, we now do various workshops, which I'll go on to later. We also, as I say, offer direct support to university for a lot of university research, not just in biosensors. We also do quite a lot in the electro-ceramics field. There's a lot of new technology coming out in piezo-ceramics that is a direct result of the use of lead in automotive applications. We also, if need be, toll manufacture for people. People have come to us with formulations and said, this isn't our core technology. We don't want to make this. Our core technology is the research. That's what we want to do. This product happens to be fantastic, but we need somebody to make it for us. So we do a lot of toll manufacturing for people. And obviously, as a result of all that, we also do quite a lot of consultancy. So the principles have basically stayed the same. Again, we still work with customers, provide materials that suit their process, provide technical support, but we also now manufacture prototypes. A lot of companies will not invest in equipment to put in a production line until they have prototypes and proven technology. And we have the ability to do that, particularly in the biosensor area. The other thing that we also realised fairly early on was in order to penetrate a lot of these markets, we had to have high quality standards. We invested in getting ISO 9001 very early on. We also then enhanced that by achieving TS 16949, which is an automotive qualification, which allows us to sell very easily into the automotive markets. And it's been an absolute positive benefit, although it caused a huge amount of pain at the time. Having gone through that process once, achieving 13485, which is the medical standard, was no great shakes, shall we say. That is actually, we are one of the very, very few companies that manufacture paste that has those two standards. And again, having achieved those two standards, we have people who actively seek us out to develop automotive components in particular for them because of the standards that we have. There's a quick look at the logos that we have on all our documentation. So what are our major product types now? Well, we're still in the electro-ceramics business. It appears to be turning around. There's more work being done in the European countries. It seems to be growing. We also manufacture quite a lot of ceramic sensors, and I've got some photos later to show you that. Biosensors, obviously, we're still in, both in paste and also in producing small-scale batches of prototypes. Automotive components, we do quite a lot in that area. Solid oxide fuel cells, which was another area that we were asked to go into, basically through consultancy. We've developed quite a lot of materials for that. Electroluminescent lamps, which is an up-and-coming business. Displays are very popular at the moment for all sorts of reasons. Flexible electronics is one of the biggest potential markets out there at the moment. It's a very new and growing area, which is something that we're actively involved in at the moment, and a lot of our work at the moment is directed in that area. And obviously we've always done gas sensors. We're still in the gas sensor area. So for those of you who haven't got a clue what these things look like, those are electro-ceramics. The white bit on there is actually silver paste. The electro-ceramic bit is the bit that does all the sensing, but it's no good unless you can actually contact onto it somehow or other. There's some examples of a variety of sensors that were printed basically onto alumina, which is a solid substrate. And this is, I think these are more concept designs really, although these are actually active sensors that we have now, of biosensors that we've developed for a variety of applications. A couple of photos of two different pieces of test instrument that actually we use with, I think the one on the left, right, well, whichever you way, that one is actually used for measuring ammonia. We work very closely with the, can't think who it was now. Oh. We work very closely with a government agency, the Environment Agency, sorry, to develop a sensor that was capable of measuring ammonia in streams out in the field, so that they could actually take these things out and measure ammonia concentrations to check for pollutants, basically. Those are electroluminescent lamps. I don't know whether people have seen these or not, but they're actually used extensively out in the Far East for posters. They don't appear to be quite so big in advertising over in Europe, but certainly in the Far East they're used extensively. And it's a technology that's new and emerging. Some flexible electronics there. As you can see, we have over here, that is actually a heater panel that is composed of carbon that is printed with a silver buzz bar down the side, which is covered in copper, and it's used for low background heating. For primarily, a lot of the Swedish homes tend to have these built into their walls for low background heat. I'm not quite sure what that top one is. This is actually an example of a in vivo glucose sensor. So that is actually that's actually put down through a hypodermic needle, which is inserted into the body, which can then measure glucose over a considerable period of time. For those of you who have no idea what paste manufacturing looks like, I just inserted a few slides so that you can actually see what we do. The top right shows you small scale manufacturing. We have a variety of different sized milling operations. You basically take your precious metal powders or whatever powder you're going to use that's going to add functionality to your paste. You add it to a resin solution which has the consistency of something like honey, but you then have to disperse that powder. And if you put it in and you don't disperse it very well, you wind up with something that looks like a very lumpy pancake mix, which is not particularly nice when you eat it. So you want to disperse it really well, and you pass that through a series of rollers basically to break down the lumps, the agglomerates, and the two pieces of equipment at the top are used for doing that. Now, the smaller equipment that we use is used generally for research purposes, but again, as I said earlier, a lot of niche products, we only sell 100 grams per year, and the customer is very happy to take 10 grams off us at a time. That is as much as they need for gas biosensors. For gas sensors rather, because it lasts a considerable period of time. So we make a single batch for them and they just take it off us in 10 gram lots. It's unbelievable. That's all we sell at a time. The two bottom pictures really are much larger scale materials. That batch down there, that's capable. We actually had that installed because the medical diagnostics people wanted to increase the batch size of the material that they were having so that they had greater consistency for longer print runs. And that's capable of doing at least 220 kilos. With a change in the vessel, we can do a 350 kilo batch of the same product. And that was one of the directives that they wanted. Printing and prototyping, we've got quite a lot of printers, all different sizes. The one on the top right is capable of printing very, very small parts, sort of down to an inch square, for various component manufacturers. The other two printers that are up there are basically used for much larger scale printing, and as an example there of just a drying unit. Our products now really are, or rather the technology and the way that the markets were moving, were becoming much more global. Now GEM actually, as a small company of 25 people, didn't employ any salespeople. We don't have reps that go out there. So a lot of the time we were kind of relying either by word of mouth, which one company to another is not going to give, or by actively seeking these companies out and trying to find people that we could work with. We had no agents either. And in global markets, you need agents. And we have no knowledge either of the business practices in a lot of these different countries. It's very different doing business with people in France to doing business with people in Germany. Believe me, it's the cultural differences mean that the way you tackle a problem is significantly different. So how do we tackle that as an issue? Trade missions. These were absolutely marvellous. We undertook this quite early on, and luckily the WDA, as it was then, Export Assist, were around to give us assistance, funding for travel. They organised events where quite a lot of companies were invited. They would also organise and support stands at exhibitions at various countries. They would set meetings up for us with potential customers, and via the consulates as well. We actually also had the ability or the opportunity to have a list of potential customers who were actually in our business area, which narrowed down a lot of the legwork that we had to do to try and find these people. As a direct result of that support, we now have agents throughout all these countries. And we wouldn't have achieved that without that level of networking, that level of support that was offered via the WDA and Export Assist. So what are the new and emerging markets? Well, displays is one, and I've showed you electroluminescent lamps. The obvious other displays are OLEDs, which are far more technical, which we're not involved with at all, apart from the silver. Well, if you don't know anything about OLEDs are principally have a limiting factor. They can only be made very small unless you can actually produce a conductive, almost invisible track that's capable of carrying the current across the whole area. Photovoltaics is, everybody knows about PVs these days. I mean, there's a lot of houses these days are invested in putting photovoltaics on their roofs, but there's basically two systems, one based on silicon, one based on a low temperature polymer type design, and we're actively involved in both of those areas. Flexible circuitry, which I've already mentioned and showed you some, plastic electronics, which is one of the main sectors that we're involved in now, and we network quite well via the KTNs on finding other people to work with within those areas. Plastic electronics at the moment is one of those areas that there is a lot of hype about, but it's very difficult to get involved because there are no supply chains put together and there's no real final products at the moment. But the potential for it is enormous. So we're actually actively pursuing and developing materials suitable for that application.